Okay, so today we're looking at 2018 AP Stats question 3. Approximately 3.5% of all children born in a certain region are from multiple births. Of the children born in the region who are from multiple births, 22% are left-handed, and those who are from single births, 11% of them are left-handed. So, the easiest way to organize this is into a tree diagram. So we have the probability of 1. We have 0.035, and then 0.965. This is multiple probability that they're from multiple birth, probability that they're from a single birth, and now we have 0.22, 0.78. This is the probability that they're left-handed, the probability that they're right-handed, and then of this, there's going to be 0.11 left-handed and 0.89 right-handed. So this tree diagram basically allows you to organize this data into a clean T-chart or tree diagram, so it's easier for you to work with. Now another good step to do is just to calculate your AND probabilities, meaning the probability that it's multiple and left. It's a really good idea to do this just to get it out of the way, because often these stats questions um, they'll ask you a simple question concerning these AND probabilities. All you have to do is multiply the 0.035 by the 0.22, and you're gonna get 0.0077, then 0.035 times 0.78, or the probability multiple and R is equal to 0.0273. Then the following 0.965 times 0.11. This is the probability that it's single and left, which is equal to 0.10615. The probability that it's single and right is 0.965 times 0.89. It's also safe to go ahead and confirm that these probabilities add to 1. 0.85885. Let's see. 0.035, 0.965, that adds to 1. Yep. 0.22, 0.78 adds to 1. Good. That also adds to 1. And now all of these values should add to 1, I believe. 0.0077 plus 0.0273 plus 0.10615 plus 0.85885, add to 1, no surprise there. Okay, good. So now we know that we did all the calculations correctly. So now we can finally look at the questions. Part A. What is the probability that a randomly selected child born in the region is left-handed? So what is the probability? What is the probability of L? Well, we found that right here. The probability that they're a multiple birth and L is 0.077. The probability that they're single birth and left-handed is 0.10615. So it's easy as simply adding these two together. So whenever you get a question like this, all you have to do is add is add um, add the two L's. Add their probabilities together. So probability M, probability N, M and L plus probability of S and L. This is going to equal 0.11385. I'm going to rewrite that because that's disgusting. 0.11385. Okay, that's the first part A done. Now let's look at part B. What is the probability that a randomly selected child born in the region is a child from a multiple birth, given that the child selected is left-handed? Okay, so for this, you should remember this very simple thing. You have your first probability, and your given. Your given probability is always your denominator. Your first probability is always your numerator. So now let's see. Given that the child is left-handed, well, we just found that probability, and the probability is 0.11385. So we can state this is equal to 0.11385. That's our denominator. And our numerator, this is slightly tricky. You have to understand here. What is the probability that a randomly selected child born in the region is a child from a multiple birth, given that the child selected is left-handed? So the actual notation is this, if this makes it any easier. Probability of m given L is equal to the probability of m and L divided by the probability of L. I think this actually makes it much easier, because if you look at it, we actually have this probability of m and L. That's right here. That's 0.077. 0.077. Sorry, 0.0077. The probability of L, well, that's just 0.11385. And then this is going to equal this is going to equal 0.0676. Now let me go through that again in a different color to actually show you what I mean. If you didn't get it the first time around. So as a general statement, we know if we're given the probability of A given B, we want to find this. This is simply equal to the probability of A and B. To make sure I'm not using incorrect symbols, I'm just going to call this AND. The probability of A and B over the probability of B. So the probability that A given B is simply equal to the probability that A and B occurred divided by the probability that B occurred. So yeah, this is just going to equal, so the probability of A and B, well, in terms of our equation, or in terms of our setup, that's the probability of M and L divided by the probability of L. M and L we found to be 0.0077, and the probability of just L is just 0.11385, therefore plug in those values, and then this is our answer for B. Let me just give the quick statement. Probability M given L. Okay. You can circle this, and we're good. Now let's look at the final part of the question, part C. A random sample of 20 children born in the region will be selected. What is the probability that the sample will have at least 3 children who are left-handed? Okay, well, let's say part C, probability that we're going to call this random variable x greater than or equal to 3. So now this is a binomial distribution, and what we're going to do is basically recall the NCR. And what you have to do for this part is because you use NCR for exact probabilities. Like if I wanted to find the probability x is equal to 1, I could use NCR, but here I have to find n choose r for 1, n choose r for 2, n choose r for 3. I add them up, and then I have to subtract 1 from that, because that gives me the complement probability. So here's what I have to do. I'm basically just going to do 20 choose 1 times 20 choose 1 times the probability that it is left-handed sorry, 0 first, because it's technically 0, 1, 2, not 1, 2, 3. That's how it's supposed to be. 0, so 0.11385. This is the probability that it is left-handed, so we don't want that yet. And then the probability of failure, the probability that it is not left-handed is 0.88615 to the 20th power. So now again, this is for n choose r if x was equal to 0. But we need greater than or equal to 3. So it's basically 1. This is basically 1 minus the probability of x is less than 2. And that's what we're going to do here. We're doing 0, 1, 2. So plus 20, choose 1. Move this over. 20, choose 1 of... Where's my mouse? Of 0.11385 to the first 0.88615 to the 19th. Remember that these exponents need to sum to your total number of trials, 20. And just be accurate with your work because you can easily screw this up. So you gotta make sure you have neat handwriting and you're not going too fast because you have plenty of time. 0.11385 second times 0.88615 to the 18th. I'm going to zoom out a smidge. Nope, never mind, it doesn't work. Control minus is not work. Okay. Whoa. Okay. So now this is going to give me this expression right here. I can say that this entire expression, this is equal to the probability that x is less than 2. But we want the probability that x is greater than or equal to 3, right? But we know that the probability that x is equal to greater than or equal to 3 is just equal to 1 minus the probability that x is less than 2. Well, once you plug this into your calculator, by the way, you get to this choose, to the n choose r, by going to math, scrolling over from math to num to complex to probability, then going down to option 3, pressing enter. In your first, and depending on, so if you have a TI-84, you do that, then it's gonna open up the blank box, see another blank box, so you just type in 22 and then the rest of your equation. But if you have the TI-84 plus CE, that it works for that. But if you have the other like the analog calculators, you have to first type in 20, then go to math, find the C, then come back and then type in your R. So this just depends on your calculator. So once you get that, this is the probability that x is greater than or equal to 3 is equal to 1 minus, forgot the value, 1 minus 0.59785. So the probability that x is greater than or equal to 3 is equal to 0.402. You should also probably define the random variable x because it wasn't defined for you. So you could just say quickly, let's go back up to the question. A random sample of, okay, what is the probability that the sample will have at least 3 children who are left-handed? So we can just say x ran variable x children who are left-handed. And then you apply your conditions on that, which we already did. We applied this greater than or equal to condition. There you go. This is sufficient work for AP Stats. Question 3 from the 2018 exam.